This is my week 7 summary for physics 131. So, this is kind of go through what we did for the week. The first thing that we did, or in Canvas, I'll talk about our discussions, and then I'll talk about our neat resources, and then we'll move into what we actually did in class. So for our discussion this week was a continuation from last week's discussion about children being disconnected from school due to not being able to be engaged as they would, say, video games. And our job was to read this article, Engage or Enrage. This talked about the 3 different types of students that there are and why it's so difficult to break the boundary between the education and video games. Pretty much the goal is to replicate the engagement students have and the attention span that they can carry in video games, some students, not all, in video games, to the education system. And I guess that's what this article is talking about doing, is trying to integrate video games into education, so then that way students can be more engaged because it's actually something they can enjoy doing. Okay, so moving on from our discussion, this is our neat resource for the week. We were to, we would be presenting a scientific poster of Project 2 during class. And so our job here was to find a good resource that would help each other out. Pretty much try to find something that would let us know or show us how to create an effective science board. And that's just what I did. So I used this website, which is really good. Had a lot of useful information on it. And I'll be following it to create my poster board. So this is what I did in class, or I'm sorry, not in class, but Monday before class. I tried to work through the spiral physics that David put up that clearly says before the first class of the week. So I did this Monday. I was able to get to a certain point, but I got it cleared up in class. But there was some things that weren't really making sense to me, but I kind of got it figured out. So, however, moving on to Tuesday, our first class of the week. The Dropbox for some reason isn't giving me the E&M, the spiral physics. It won't let me see or download the packet that I need, so I'll just have to talk about it through pictures that I have. So this is a picture of page 41 we worked through. This is the equation we derived from it. We have this picture here shows our x, our radius, and our ds. It's pretty much using integral. We used a lot of integral calculus to determine the charge, infinitely to the right. It was for this one. So same kind of thing here. We'll get to our board. So this part was kind of confusing to me, which after some more practice, it started to make sense, but for the most part, it's just using our calculus skills to integrate. I wasn't 100% sure what a unit vector was. This was kind of new to me, but this expression didn't make sense at first, but after David went over it, I now know what a unit vector is, so that's good. This is our board. This is page 11. And so just matching it up, this is our derived equation for page 11. Same thing here. Okay, so moving on from what we did here, we did that for maybe the first half of the class, and now we moved on to what is it? Electric field hockey is what it's called. It's a video game. Not a video game, but a game on the computer that we played, that we tried to move a positively charged orb, I guess, around these barriers using positive and negative charges. It was actually really fun at first. So you have to understand how these charges behave, so the more of them you have, the stronger it will be. And after you did that, you could pretty much learn how to maneuver your way through these barriers and try to get it into the goal. The puck into the goal. So we did that for the rest of class. Again, this is level 2. Wasn't too difficult. Level 3, the one I showed you previously, was the hard one. But yeah, we just used our charges to attract the puck where it needed to go to get into the goal. Okay, so moving on to Thursday. Give me a second. Let's see. So yeah, moving on to Thursday. Well, before we go there, I want to talk about Canvas a little bit more. We had a grade check, or we just had a grade that all we did was enter the grade we were pursuing. And for me, that is a B, which I feel like I'm doing pretty well pursuing that, following the instructions in the syllabus for that particular grade. So next we have EFH Champions, which is the game that I showed you previously. So we had to complete it correctly and then submit it. And then we have gravitational and electrical equipotential. So that was again on Tuesday that we had to do that, which was what I kind of went over before. Okay, this is part of Thursday, so we'll move to Thursday now. So in class on Thursday, I'll start here. So when we came into class, David had this worksheet set up, or this sheet set up with each of our names on it, and we were calculating based off the step we were given. We were calculating our electric, or our potential, our energy potential, and for each of us. So the cool thing about this was that after we went through and divided, even though we all had different numbers, we went through and divided by a certain number, and our constant was like 5.2, it would decrease. So for the steps that you went down, it would decrease by 5 point something. I'm not too sure on the numbers. I don't have it in front of me. But okay, so continuing on from that, David gave us these equations that allowed us to calculate each of these given things. So we have our force, field strength, energy, and potential. Okay, so here's the problem we were given. That's our board. Here's the problem we were given. We had A, B, C, and D. This is out of the spiral physics packet again. And so each of the questions we had we did A, B, and C, and D. These are all pretty straightforward. We just used the equations we were given to solve for what we were asked to find. I don't think I'll need very much work with this. Just pretty much plug and chug. So D was kind of a conceptual question, and we had potential doesn't involve mass, but energy does, which was the point it tried to get across to us. So I showed you that. This was the second one that we did. Same thing. We just a little bit more to do here, but we pretty much just plugged in our numbers with our equations. Those are my notes. These are my notes for what I took in class Thursday. And then here is, well, that's Nico, and then here is a mountain, a camelback mountain that David showed us, and he said each of these little ripples around it had the same equipotential, which is a term that we learned in class on Thursday, which pretty much says that at each of those points your height won't change, so you'll have the potential will be equal no matter where you are around that same height. I mean, if you're on the same height, as long as you don't, go up the mountain or down the mountain. So that pretty much sums up what we did for week 7. Other than that, we did a VPython extension where we had an orbital, and we tried to modify the code, getting that to work a certain way, just playing with it, understanding how the code works. So, but yeah, that pretty much wraps up week 7 summary. It was a pretty productive week in this class, so yeah. Thanks.